Alright, so in this video we are going to see types of inheritance in Python. So basically there are two types of inheritance. One is single inheritance and the second one is multiple inheritance. Multiple inheritance. Now on the basis of these two inheritance we can combine them and we can create another types of inheritance also, but basically there are two types. So now let's see this one by one. So in single inheritance, see, whenever we derived a subclass from a single base class, then it is called single inheritance. It's that simple. What I said is, when we derived a subclass, let's say we derived a subclass B from a single base class, let's say A, then it will be a single inheritance. There will be only one parent from which one or more than one child are derived. So this is single inheritance. Okay, there will be only one base class and there can be one or more than one children classes can be there, but base class will be only one. So this is the single inheritance. And how we inherit, we already know. We just write like this. The subclass, we will write the subclass, and inside the bracket we will write the base class like this. So this means is B is inheriting the class A. Now whatever will be the data members of A, let's say A will be having some data members, so B will be also having those data members, plus it can have its own additional data members. So that's what happened when we do the inheritance. Now let's see multiple inheritance. Multiple inheritance is also something like this only, but the only difference is when we derived a base class from multiple base classes, when we derived a subclass from multiple base classes. What I mean to say, let's say the subclass will be, or the children class will be, let's say D is the derived class, and it is derived from the classes, let's say from the class A, it is derived from class B. So you can see that there are multiple base classes from which a class D is derived. So this is the basic example of multiple inheritance. Now again, it is like there can be one derived class or more than one derived class from the same parents. So this can be also be a multiple inheritance. Now again, there can be two parents classes or three parent classes. So like this. And the thing is, we need to know who is parent, so this arrow is important like this. So that's the thing. So the multiple inheritance is when we derived a subclass from multiple base classes, and those base classes can be two or more than two base classes, and the derived classes can also be one or more than one. Now how we derived in practical, it is very simple. We already know. We just write like this. We write like this. We write the derived class name and its parents name, let's say A, B, like this. D class is derived from A and B, and suppose it is also deriving from another class C, so we will write like comma C. So like this we write in our practicals. That's it. Thank you.
Okay, so now we will see the behavior of the classes in multiple inheritance. Alright, so this is an example of a multiple inheritance, and this is the picture of this example. So what is happening here, there is a class A and there is a class B, and then there is a class C who is inherited from class A as a first parent and class B as a second parent. So this is the basic diagram of this program. Now we can see I have written here object. So this object is a base class for everything we have in our Python. So this object is the super class of everyone. So it is by default, it is there, and no need to mention it in our program. Even if I write it here like this object, it won't show any error because everyone is inherited from object class only. So even we can write like this, or even if we won't write, it won't show any error. Okay, so now coming to the point, this is our class C, which is inherited from A and B. All right. So now this is our class A, class B, and class C, which is inherited from A and B, and we write it like this. Now I have created an object of class C. If I run this program, what will happen? See, if I run this program, in this case, a constructor will be accessed. Now, if we can see here in class C, do we have any constructor here? No, we don't have anything inside the C class. So what will happen? This object, it will look for the constructor in the parent classes. Now the thing is, we have two parent, class A and class B. Whose constructor he will access? Okay, so this is the first rule. Or this is the rule that every time every time what happen is compiler will search in the subclass first. It will search inside the C first. Is there is any constructor or method that we are looking for? If the answer is no, then it will check for the first parent class. First parent class means which is at the left side of the this declaration. Like here in the left side it is A. So then after looking inside the subclass, if it won't get a data members, it will look for the leftmost parent class. Then it will go inside this A. So if I run this program here, I can see that the answer will come inside A. Okay, that's the first thing. But suppose if there is also nothing, if in first parent there is also no no constructor or no data member is found, then in that case compiler will go to the second parent class. So now if I run this again, I can see that it will show inside B. So that's what happened. But suppose okay, what happen if B also does not have it? I don't know. Let's see what will happen. I think it won't show anything because it will go to the object class, and object class have inside it. Object class have this constructor inside it, but I don't think it will print anything. Let's see. Even I'm not sure. So if I run this now, what will happen? It will show nothing, but the program will run without any error. Now what will happen if in the first search only, if in the first search only our compiler finds the constructor inside C class? Let's see. Inside, let me write it C. Okay, now if I run this, it will show inside the class C. So that's how these things are compiled, or the classes are visited in multiple inheritance. So that is the first thing. Always subclass will be searched first, then the first parent class which is at the leftmost side, then the second leftmost side, and suppose if there is like C, D, so like this, after B the C will be searched, after C the D will be searched. So like this visiting happens. Now that's the first part. Now the second part. So the second part is, whenever we created an object and we run the program, it is only accessing the data member, or in this case the constructor of the subclass only. What about the constructors of the parent class A and parent class B? What if we want to access both of them? How we can do this, we will see now. Okay, So to access that, we already know we have a method called super method. So in that case, we will write inside this subclass, or we can write it outside also, but just for the simplification and for the understanding, I'm writing it inside. We will write super method like this, dot what? Dot the method name that we want to access of the parent class. In our case, we want to access init method, right? So that's why I will write the init name and this. Now what will happen? See what will happen now. If I run this program, it will look for the constructor inside it and it will print inside C. Then it will go to the super init. Now it has two parents, A and B. Now you already know which parent will be visited first, the leftmost side, the A one. So it will show first, the output will be like inside C and inside A. That's it. Then it will stop the search. Now if I run this, you can see inside C first and then it will go inside A. Now similarly, if I write the same line super.init method inside class A, now what will happen? It will go to the object class and it will show the object class, right? The answer is no. It will not go to the object, or it will not go to the its parent class. Why? Because this is also a rule. This is also a rule. The rule what says is the subclass are visited first. That's the first thing, and no parent class can be visited before the children are visited completely. That's the one more rule. What I said, no parent class will be visited before its subclasses or its children classes are visited fully. So if we see in this example, A and B are the childrens of class objects. So after encountering super.init in class A, even if the super will tell it to go to the object class, it will not go to the object because object's childrens A and B are not fully visited. After A, so it will go to the class B. So that's what it will happen in this case. So if I run this, it should show inside C, inside A, and then inside B. So if I run this, it will show me inside C, inside A, and then inside B. Now what will happen if I write this same super.init inside this object B? Then it will show nothing. It will show the same output, but even then this super init will go to the objects class init. So that's what happened. So if I run this, it will show the same output like this. So that's the thing. Now so this the way this classes are visited, or the way the methods are searched, methods are looked inside the classes, this is called the method resolution order, the order in which the classes are visited. So this is called MRO, method resolution order. So we can see this also in our here. So if we write print and if we write the class name, we need to write here the class name, okay, dot MRO, and if we run it, then we can see that it is showing the way of visiting the classes. So it is visiting C, then class A, then second parent B, and then object class. So this is the thing. Now why this MRO? I mean, see, even if I won't write anything, okay, even if I won't write anything in the body of this classes, let's say I write it here pass, I am not writing anything, any data member or anything. If I just comment them, and I write the pass and pass, now what will happen? See, there is nothing inside it. Even then the compiler will visit these classes in the same order. First it will visit the subclass C, then it first parent class A, and then the B, and then the object class. And we can see that through print.mro on this line statement. So let me clear this, and if I run this, we can see that this is the MRO of this particular program. C first, A, B, and then objects. So that's it, and we will see the MRO in our next video. Thanks. Alright, so let's see MRO in more detail. So what is MRO now? Method resolution order. So this is the way of searching any attribute or any data member in the multiple inheritance, or in any normal way. The way of searching is this MRO. Now let's understand this MRO and what it does. So this MRO, it follows like basically three principles. The first principle says that in this MRO, how it searches the classes, how it visited the classes, how it searches for the data member are, first of all, it will search the subclass. All right, we already saw it will search the subclass, and it will search it fully. It will search it all, the subclass. After searching it, it will go to the first parent class, which is at the leftmost side. This is the second one. The first principle is it will always search the subclass first. After searching the subclass, it will go to the parent class, the leftmost parent class, and then if there is any other parent at the second leftmost, it will go to that one. So like this, like in this case, after searching inside the C class, the A class will be searched, and after searching A class, the B class will be searched. That's the principle. And after visiting any class, let's say after visiting the class C fully, the MRO will not visit this class again. It is visited only once. It will be visited only once and full, and it will not be visited second time. That's the third principle. And the one more thing is, no parent class will be visited before its children are visited completely. That's the one more thing. That's the fourth point we can say. So that are the things with the MRO. Number one, the subclass will be visited fully. After that, the leftmost parent will be visited first. Then the second leftmost parent will be visited first. In this case, A first, B first, and no class will be visited again if it is visited once completely, and no parent will be visited before its children are visited completely. That's the rule of this MRO. So that's the thing. So we have some examples here, so it will be very easy and it will make it more clear. So if we see this, so what is happening here? C is inheriting from B and B is inheriting from A. So here the MRO will be simple. The first it will visit the C, then it will visit B, then it will visit A. So that's why I'm not showing it in program, but that's what it will happen. Its MRO will be like C, then B, and then A. So that will be its MRO. But if we see this program, okay, if we see this one where D is inherited from B and C, and B is inherited from A and C is inherited from A. So this is the structure of this program. A is the class, B is B is the class inherited from A, C is the class inherited from A, and D is the class inherited from B and C. So that is the thing. So if we again write super here to just access the method of this classes, we can write it, but let's not write any super thing. You already understand, I hope. So if I just show you the MRO here, I'll just write print class is D, I think, yeah, D dot MRO let me clear this one. If I run this, so what will be the MRO of this program? This diagram, what will the MRO see? First of all, D will be visited, no doubt. Then the leftmost, this is the leftmost. After D, the leftmost is B class, and then C class. So that's why B will be visited. After that, B has, see, after that, after visiting B, it will go inside this B, and it will see that B also have a parent class A. So it it will go here, okay. The thing is, I will tell you later, but it cannot go to the A because A already have a children C, and we already saw, I mean, we already know that the children will be visited first before its parents are visited. So that's why instead of going to A from B, it will show us, it will come to the C class here. Instead of going to the A class, because A class already have a children C which is not visited, so from B it will go to the C, and from C it will go to the A class. So that will, so what will be the MRO of this? MRO will be D, then B, then C, and then A. So if we run this, we can see that the constructor is initiated here, which is showing D, and we have not write any super method here, so that's why we are not going to any parent classes to access the constructor. But still we can see the MRO as first it is showing D, then B, then C, then A, and then the object class, which is the parent class of this all. So that's the MRO of this particular case. So that's the thing. Now let's see another, this one. Okay, so now you can guess what is the MRO of this. So the D is inherited from the C first, and then B, and C is inherited from A. So its MRO will be, any guess? You already know, I think. D will be visited first, after that C, after that A, and then B, and then the object class. So that's how it should work. Let's run this. This is the same program I have written. A is a class, B is a class, and C is inherited from A, and D is inherited from C and B. So if we run this, let me clear this. And if I run this display show, if I run, if I write print d.mro, we can see the MRO of this. So the D is visited first, then C, then A, then B, and then the object class. And in this program, in this particular program, if you have noticed, in the previous I was using this init method, which is the constructor. In this previous also we have seen through init method, but in this program I have wrote the display method, right? So I have wrote this for a purpose. So I will tell you this later. Let's complete this MRO first. Now let's come to the case number 5. Let's come to the case number 5. Okay, so this is a inheritance, all right, and this one is a special case. So if you can see here, there is a class A and there is a class C which is inherited from A and B is inherited from A. This is no doubt, and I have written this same diagram in here. Class A is written here and class B is written, which is inheriting class A. But if I try to write the class C here, let me write class C here. Class C, which is inheriting what? Which is inheriting A first and then B first. So if I write A comma B, and if I write this init method here, it will show me error. It is showing some red line inside C. It means this is not possible, or it is some error are there. That MRO is not possible in this case. I will tell you why, but still it is showing error. Here cannot create consistent method ordering pylons. So that's what it is showing. So if I create a objects, let's say obj1 and of the class C, and if I print our MRO of class, what was the class? C, right? C dot MRO. Okay, if I run this, it will show error because the MRO is not possible in this case. Cannot create a consistent method resolution order for the base class A and B. Why this MRO is not possible in this case? See, because we already know the rules, right? First the subclass will be visited, that is correct, but after that what will happen? It will go to the parent class. But which parent class? The leftmost parent class, and here the leftmost parent class is class A, so definitely this will visited. But again, a parent class cannot be visited before its subclass is visited, its children class is visited. So there is a conflict, like in multiple inheritance it's saying that visit the leftmost parent class first, but also the subclass will be visited completely first, only then the parent class can be visited or can be displayed or as searched for, looked for. So so this is not possible in this case, and that's why we are getting this error that cannot create a consistent method resolution for base class A and B. So we should be very careful while ordering these classes sometimes. I mean, it won't happen very frequently, but we can have this little awareness or little how to write the classes. So to correct this program, what we can do is we can reverse the order of these parent classes. So then it will work perfectly. So if I reverse the order, then if I run this, it will show that the C is visited first, then the class B, and then the class A. So that, and then the objects. So that's how this MRO works. Now let's just the final one. Let's complete this through this. So what will the MRO of this one? What will be the MRO of this one? And I cannot access my red pen. Why? Okay, now I can access. Okay, so the MRO of this will be, it is very simple. I think you can know by now. It will show us F first. This will be the first. Then it will go to the leftmost side D. Then it will go to the A. Okay, then it will go to what? It cannot go to B. It will go to E. And then it will go to B, and then C. So that will be the order: F, D, E, F, D, A, then E, then B, then C. So this is the same program I have written. We have made class A, class B, class C individual. Then this class D is inheriting from A and B. Class E is inheriting from B and C. Class F is inherited from D, E, and C, and that's the thing. Okay, so if we see the MRO first without displaying the objects here, I mean without accessing the display method, we can see the MRO. If I run this, we can see the MRO in the order F, D. We can compare simultaneously, then A, then E, then B, then C, and then the object class. So that's how the MRO works. I hope MRO is clear, but one more thing with the super I want to tell in this same thing. Okay, let's come to the point here. this one. I told you, right? I have used here display method, and in all the previous methods we were using the init, the constructor. Here also we use init, here also we use init, but here we have used this display method. Now there is a not problem, but this thing we should just know that see the use of super, how we should be careful with the use of super. See, I want to access what display method. So here if I run this program, it will show me the D, because it will first look for the display in D only, and it will stop here because I have not used any super method here. So if I run this, it will show me D only, like this, D and then the MRO. But what if I want to access the display of the parent classes also? So what I will write, we already know, I will write super method with the method name. Here in our class method name is display, like this. So if I write this, it will go to C only, C, and it will print C, and it will stop here. If I run this, it will show me D and C, and it will stop. It will stop at C because in C I have not used any super method, and it is accessing this through this MRO basis, right? So if I write it here, then it will go to what next class, which is what, which is A. So it will go to the A then here. Let me run this. Okay, it will show me D, C and A. D, C and A. Then again, if in A we write the super, it will go to what, B class. Alright, if I write it here again, it will go to the B class. Let me clear this. It will go to the DCA and then it will go to the B class. Now here comes the thing. This is the important thing. See, the picture of our this particular program is like this. This is our this. It is going to D, then C, then A. Okay, then it will search for the from this super.display inside A. It is searching for the display method in B here. But now what will happen if I write super.display in B also? The thing is, if I write super.display in B, what will happen is from B, after printing B, it will go to its parent class, which is object class. But the thing is, our object class does not have this display method, so it will show us error. If we run this now after writing super in B class, it will show me error like this. It is showing attribute error, super object has no attribute display. So that's the thing, we should be careful that where we are using the super. I mean the super is available in A, C, D. That's why when we are using this, I mean display method is available in A, B, C, D classes. So that's why super.display method, this line was working. But in this last class of this MRO, when we are writing this super.any method name which is not available in the object class, so it was showing us error. So the solution is to remove it from this. So that's, if we run this now, it will run perfectly nice. So that's the thing. Now if you can see, in it is available in the object class, so that's why it is working. But we cannot see the, I don't know we can see or not, but we can see. Okay, so we can see in help. If I write it here, in it method, and enter, we can see here the signature of this, like method wrapper in it, that's the constructor of module object. So I mean this is in the object class. So that's the thing. And anything else, yeah, no. And the same thing, I mean, I hope you understand this case where we need to use super and why it was showing us error. Similarly, in this case also, in this particular case, the last one, I have used this display method, and its last MRO, the MRO of this particular program was, if I run this, it was like this. The MRO was like F, then D, then A, we can see, we can compare simultaneously, then E, then B, then C. So if in class C we write this super dot display, it will show an error because there is no display method in object class. Like this, it will show us. Why it is not showing us error? It should show us error. Yeah, it is not showing us error because this display is not is visited. I mean, we are not displaying this visit, we are not accessing the display method. Even then we have wrote the statement here that super dot display should be visited, but we are not calling this, we are not calling, so there is no there is no sense of writing this. So we need to uncomment this one, and now if we run this, it will show us error. See, and if we remove this from the last class C, commenting this, then it will run perfectly fine. So that's how this MRO works, and that's how we should be careful while declaring the inheritance classes and accessing the methods and the use of the super, those things. So that's the thing. And if you want to see that MRO's algorithm of Python, that 3.x, you can see this is the algorithm C3 linearization. So C3 superclass linearization is an algorithm used by, so you can read this one. This is the algorithm. And thank you. If you have any doubts, you can explore by yourself or you can comment. We will try to find it out. Okay, thank you.